Hello there. Starting with the introduction to organic chemistry. So hydrogen is group 1A and carbon is in the group 4A, right? Also, if you remember von Clow-Bridge, it depends on the lowering the electronegativity is important for functional group studies. Let's go back to 1A. Hydrogen has 1 valence and 4A carbon, group carbon, has 4 valence electrons. You can write them with the from bottom to top filling the electron configuration 1s2, 2s2, 2p2, right? And this build-up can be written as this fashion. So 1s2, 2s2, and there's p, x, y, z. There's 3 orbitals, right? So the energy is increasing, or electrons are filling from bottom to top, is called the Aufbau principle, and this pairing is called the Pauli's exclusion principle. So you learned in the Gen Chem, and this px, py, and pz is separately filling one at a time based on the Hund's rule, right? This writing is called the ground state, where if the electrons go up because of the thermal energy, it's called the excited state, right? That's later. Just the terminology, you probably have seen them, right? So let's get this one. Hydrogen to hydrogen has a 1 bond at single or sigma bond. It's a covalent bond shared each electron from each atom. Similarly, I can put carbon has 4 valence and it can share with hydrogens, making 4 single bonds. Why do we make 4 bonds? Because just to satisfy octet. So that means carbon needs 4 bonds, right? Okay, so now we're going to try to learn how to draw various organic chemistry structures. We are building based on the single bond, sigma bond, just same as H to H bond, right? In this case, you have H to C bonds. That's a paired electron making the bond. You can write with the line diagram. That's actually the Lewis structure. If you take 2 methanes, in this case, CH4 is a methane. You take 2 methanes, remove 2 hydrogens, and hook up the 2 molecules, and it'll look like this, correct? Right? Because carbon needs 4 bonds. I'm going to add another carbon and another carbon. You can add as many as you want, right? So in this case, I have 4 carbons, and so each carbon needs 4 bonds to satisfy the octet. So I have done that. You see, each carbon has 4 lines, 4 bonds, right? Okay. Now, that's called the Lewis structure, or also called the expanded structural formula. So showing all the bonds and hydrogens. We can condense that to get the condensed structural formula. What do you do? This one is CH3, then CH2, then CH2, then CH3. Now, you can pause the video and draw it, okay? And then we can also write the bond line angle, or we call the zigzag, or the carbon skeleton, like this way. This means CH3 is each corner and the vertices are the CH2s, right? And this bond angle represents 109 tetrahedral carbon, which is super important to understand as you go, right? Now, these 2 can be used to write the molecular formula. Just count the carbon C4, hydrogens H10, and that's the molecular formula. And then we can write a generic, if you can, CnH2n plus 2. Those ones are called the alkene homologous series. Okay, now I'm jumping to the next one. You can pause and take a break, right? So double bond. So oxygen has a double bond. You should know that from your Gen Chem. Then same as carbon can get double bond, right? Because it needs 4 bonds. I can put 2 of the carbon to carbon, which is a double bond. Then satisfy the 4 bonds for each, right? CH, CH3, yes. Now each carbon has 4 bonds. This angle is actually 120, showing the trigonal planar. Planar means actually flat. Now, so we have drawn that one, the structural formula. Let's get the condense. CH2 at the beginning, double bond, CH, and finally CH3. So that's the condensed lines. CH3 is a corner, vertex has a double bond to starting with the first carbon. So it also indicates pi and the sigma bonds, right? Okay, now formula, molecular formula is count the carbons in the condensed C3H6, and that means the general is CnH2n. That's called the alkene, ENE. So that's another homologous series. Okay, now think about the nitrogen has a triple bond, right? So there's 2 pi bonds and 1 sigma actually, okay? But let's say triple bond. I'm going to start with the carbon having a triple bond and connects bunch of carbons, and then first carbon needs 1 hydrogen, the second carbon needs no hydrogen, other ones need 2, 2, 3 here, right? Now each carbon has 4 bonds satisfied, right? We start with the triple bond. Okay, now this angle is actually 180. It's showing the linear molecular shape for that part of the molecule. Condensed formula. So HC, triple bond C, then a CH2, then a CH2, then a CH3, right? That's what it indicates. So now the molecular formula is count the carbon C5, count the hydrogens H8. The generic is CnH2n-2. So that's called the alkynes, right? So that's another homologous series, right? There's 2 pi bonds in the triple bond, 1 sigma. Okay, that's simply called the triple bond, just like nitrogen. Okay, all right. Now, so I'm going to teach you 2 additional things here. Okay, that is the homologous series. So now we talked about alkanes, alkenes having 1 double bond at least, and alkynes having 1 triple bond at least. So the alkanes have all the single bonds, correct? So all sigma bonds, all single bonds, at least 1 pi in the alkene or 1 double bond, at least 2 pi or the 1 triple bond in the alkyne. So the generic formulas are like that: Cn2n plus 2, Cn2n, CnH2n, right? And then CnH2n minus 2. So that's the generic formulas, right? And the names ends up with the alkane, alkene, alkyne. That's how the names ends up with, right? And these ones are called the homologous series. All 3 of them have homologous series. That means they have a general formula like above, and then they probably separate by a CH2 group, and they have similar chemical and physical properties. That's the nature of homologous series. There's a whole bunch of hydrocarbons like that, right? Now, we're going to name next one, but I'm going to put you some hints here how to name. You need to know number of carbons. That's, let's say, 1, 2, 3 up to 10. And they're named as 1 is meth, 2 is eth, 3 is prop, 4 but, 5 pent, 6 hex, 7 hept, oct for 8, non for 9, 10 for dec. That's it.